Okay, YouTube, this is my first video in a series on that I'm doing on ellipses. Okay, so in terms of conic sections, ellipses, what are these things? A lot of people just kind of look at them as kind of like ovals, or they look like a circle that's been sat on, a little bit crushed. Okay, so what I want to do is I actually want to relate an ellipse really quickly here to a circle, but we basically say that in a circle, we would say that a circle is usually given by some equation x squared plus y squared equals r squared, where r is the radius. And I'm saying that more generally we say that the equation of a circle is x squared plus, x minus h squared plus y minus k squared equals r squared, where h and k are the center of the circle. The thing with conic sections in equations of circles here is that we are always going to learn that we want this on the right side to be equal to 1. So the idea is that I'm going to divide everything by this r squared here, and we end up with this x minus h squared over r squared plus y minus k squared over r squared, over r squared, and this is equal to 1. And the idea here is that h and k will tell us where the center are, but in a circle, the interesting thing is that these two values down here are identical. What I want to do is I want to kind of look at, well, what would be true about something here if this value under here and this value under here were not the same? They didn't, go out the same amount of space each way, left, right, up, and down from the center. Okay, then we would be producing what we call an ellipse. And an ellipse, a circle, is the collection or locus of all points that are equidistant from the center. An ellipse is defined a little bit differently, and what we do is we say that every ellipse has two foci. Okay, so let's describe the anatomy of an ellipse here. We have this ovular thing, looks like an oval, and we see that it has a longer axis and a shorter axis. So we're going to call the major axis the longer of the two axes, and the minor axis the shorter of the two axes. So one thing to keep in mind here is that we often classify half of the major axis as being the semi-major axis, and we use the letter A to represent the length of the semi-major axis. Okay, we use the letter B to represent the length of the semi-minor axis. So in general, we could say that given an ellipse, the whole major axis has a length of 2a, and the whole minor axis has a length of 2b. The other thing I want everybody to recognize here is that there is a center in this ellipse, and the center is always at the point hk. So this hk is going to be very important here when we look at h and k, very much the same as when you look at a circle. That's where the center lies. And then we say, last but not least, we say that every ellipse here, if I say that this is my major axis and this is my minor axis, has two foci. Okay, so the definition of an ellipse really quickly here is simply this. If I pop over to geometry utility here and we say let's put in an ellipse, it says select two foci and a point on the ellipse. So here's my ellipse right here. You'll notice that we have a major axis and a minor axis. If I were to say where would the midpoint be, or sorry, where would the center of this be, I would say it's the midpoint of the two foci always, and it's just this point D here, and that the major axis runs through those things. What makes an ellipse is the fact that if you were to put a point on the outside and connect that point to both this focus and that focus, we call these the focal chords, and then we'll measure the distance of both of these focal chords. So like here to here, here to here. We notice that 2.53 plus 3.47, if you add those up, you get 7. But the idea is it wouldn't matter where I put this point on here. I would say like maybe right here. I get 3. Oh, you get 6. My bad. 3 plus 3 is 6. Add these together, you get 6. Add these together, you get 6. Add this together. Here, you would get 5 plus 1 is 6. So the idea is that no matter where you go on this ellipse, this point will always have the sum of its focal chords summing up to be a constant. Okay, so that is our definition of an ellipse. Okay, and we're going to talk about what its equation looks like in standard form. So we say the standard form of the equation of an ellipse has a center at hk, and its major and minor axes of lengths 2a and 2b respectively. So the same thing we set up here. We say a is the semi-major length, or the semi-major axis length, half of the major axis. B is half of the minor axis. So the whole axes have 2a and 2b respectively. And this is very important, but we say b is always smaller than a. So we say a is the bigger of the numbers. But we say here are their equations. So the first thing I want everybody to notice here is that we have x minus h squared plus y minus k squared. This is very much the same as when you look at a circle. And instead of being equal to r squared, it's equal to 1. Must be equal to 1 all the time. Okay, equal to 1. So the difference between this and a circle is that once this is equal to 1, instead of having r squared and r squared down here, we have two different values essentially. And we say a squared and b squared, where a is half of the length of the semi-major axis, or is the semi-major axis. And we say b is half the length of the minor axis, and we're just squaring those out, okay? So we say that if we were to switch a and b's orientation around, that is, the bigger of the two numbers was underneath the x value, then our major axis is going to be horizontal. We would draw an ellipse that looks like this. Here's our major axis, okay? And if we have the bigger of the two numbers underneath the y value here, we have a major axis that runs north-south like this, okay? So in either instance, HK is the center of this. So now the foci. The important thing to know about the foci is that the foci always lie on the major axis, and we say that they lie c units from the center. So that is to say that on this first hypothetical ellipse here, we would say that A is half the distance on the major axis. We say B is half the distance on the minor axis here. So we have A and B. Then we say that this distance here is equal to C. So we say A, semi-major, and then we say B is the semi-minor, and then we say C is distance from center to a focus, of which our ellipse has two foci, okay? So we'd say that C is this distance from the center out to here. That is our distance C here. But it is important to note with ellipses that C is equal to a squared minus b squared. So if you want to remember this with ellipses, I just remember this. It almost looks Pythagorean, a squared plus b squared bc squared, but it's not. It's got a difference in here. But that tells us how far it is to get to a focus from the center of this ellipse. So really quickly, if the center is at 0, 0, if h and k are 0 and 0, these formulas collapse and they just become x squared plus y squared equals 1, but over these respective parts that are different from one another, okay? So major axis horizontal would mean our bigger of our two values down here is underneath the x, and we say that if the major axis is vertical this way, then our bigger of the two values is underneath our y. Okay. So what we want to do is this. We want to find the standard form of the equation of an ellipse having this for a focus, and a major axis of length 6. So this being our very first time, I say that we always draw a picture of what we know. So just drawing this out, I know that at 0, 1 we have a point on our ellipse and it's a focus. And I say 4, 1 is also on this ellipse right here as a focus. So using what I know about ellipses here, and also that I have a major axis length of 6, I want to sketch in this ellipse, but using already what I know about ellipses, I know that the major axis goes through the foci here, or that the foci have to lie on the major axis. So the midpoint of these 2 points is going to be the center. So we say the center is pinpointed at being at 2, 1 right there. We need to know this because this is our h and our k value. And then we also know that if the major axis has a length of 6 totally, then we say the out to the outside of this ellipse, we would go 3 to the right and 3 to the left. So these points must also be on the ellipse right there. Okay. So we have now the major axis length of 6. We know since the whole major is 2a, then we say a is 3. So now we know a equals 3. If we are going to write the equation of this, I'll make it real simple for you. It's got to look like this. And in either instance, we say that we have an x squared and a y squared term, whether your axis is going horizontally or vertically. And the very first things what we're going to do, we're going to need to find a and b for down here. And we're going to need to find h and k. So the h and k are now apparent to us. We'd say this would be minus a 2, minus a 1. So here are h and k respectively, both dishonest. Our a value here is 3. So now I know that our major axis runs left-right. So that 3 right there is going to go underneath the x value here, because whatever's underneath the x value tells us how far left and right we go from the center, which is 2, 1, in a horizontal sense. So now we got to say, well, what is our b value here? The trick comes in this. We're always going to remember that c equals a squared minus b squared, where a is the bigger number with ellipses. So here's the deal. Out of A, B, and C, we should have listed these all. We could actually determine that C is this distance here from the center to a focus. We already know this is 2. So we could work backwards to figure out then what does this B have to be right here. And we could say that 2 squared, which is our C squared, is equal to A squared, which is 3 squared minus B squared. So we would get 4 equals 9 minus B squared. If we subtract 9 from 4, we get negative 5 equals negative B squared. So B is equal to the square root of 5. Positive square root of 5. So I'll put the square root of 5 down here, and I would say then we could say that we would go the square root of 5 up from the origin, that's about, or from the center, that's about 2 and some change, and square root of 5 down from the center, and we would land at those points right there. So here is our ellipse when we sketch it, and we could label all of these points knowing the fact that we were leaving from the center, and the center was 2, 1, and we went so far left and right, up and down from this. So again, let's try this one more time. Find the standard form of the equation. We have foci here and here, and a major axis length of 10. Then we have a focus at negative 2, 2, and 4, 2. So these are foci. So the center has to be the midpoint of those two. So we say the center is at 1, 2. So we have H and K. Now we need A, B, and C. Do we know these things? Well, knowing that the major axis has a length of 10, we could say we go out 1, 2, 3, 4, 5 this way, and 1, 2, 3, 4, 5 this way. We could say that, yeah, then I kind of know that A is a length of 5. Okay. How about this? The distance from here to a focus. This C value here. We say C is 3. So if we're going to write the equation of this, we have x squared plus y squared all equal to 1, and then we have a squared and b squared depending upon where they need to go. So we'd say x and y. We say our center is at 2, 1, so we say x minus 1, y minus k, which is 2. And then we see that our major axis must run left-right because the foci are on this here, and they run left-right. So we'd say, all right, well, left-right means that our major axis value goes underneath the x value. So we say this 5 goes underneath here. And we say, well, what's the value of b to put under here? Again, we could say 3 squared, which is our c squared, equals a squared minus b squared. So now we get 9 equals 25 minus b squared. We get negative 16 equals negative b squared. So this basically implies that b equals 4. So we have 4 right here, okay? And so we say that I'd put a 4 in underneath this, and it means from the center I'm going to go 1, 2, 3, 4 up, and 1, 2, 3, 4 down to get to those points there on my semi-minor axis length. Okay, or my minor axis has 8. The whole thing is 8. So those are what ellipses are, and those are how you would graph them using these equations. Cheers.